So now let's talk about the M2 measure. This is our last metric that we are going to discuss. M2 or M square, it is named after Franco Modigliani, Nobel laureate, professor at MIT, and his daughter who worked at Goldman Sachs. So this is named after them, Modigliani and Modigliani square measure, right? This is as I have listed here in the heading. This is a variation of Sharpe ratio. So now our Sharpe metric that we calculated here, zero point 0.5. Uh, it's a little hard to interpret. I mean, what does zero point 0.5 mean by itself? It's a unitless number. It's not in percentage terms. Is it good? Is it bad? It's hard to say. So ideally, what we want is our performance evaluation metric to be in percentage terms, right? So if I have like a percentage number, that would be easy to interpret, and that is really the idea behind this M2 measure. So this is a risk matching technique. The risk of the portfolio, in this case the sigma, is matched to that of the benchmark by using treasury bills, right? So by mixing in with treasury bills, either adding treasury bills or creating leverage using treasury bills, we can decrease the risk of the portfolio and match it with that of the market portfolio or the benchmark portfolio. And once the risk is matched, then we can simply focus on the return, right? So same risk, we can then just compare the return to see if the return is higher or lower and by how much. So I'm going to go straight to the example to illustrate how this M2 technique works. Okay, so these are the numbers that we are looking at. We have the managed portfolio, the one that we are evaluating, right? Its return over the past time period, whatever that time period might be, it's 35% return with 42% standard deviation. The benchmark is the market portfolio. Market portfolio over that same time period has a return of 28% and a standard deviation of 30%. So you can see that this portfolio that we are evaluating has higher return but also higher risk, right? So we cannot say for sure whether this portfolio did better or worse than the market portfolio based on a risk adjusted basis, right? So again, remember, this is not just about returns, it's about risk as well, right? So we need to adjust for risk. All right, and over that same time period, the treasury bill rate, which is our risk-free asset, is 6%, and of course it's risk-free, so it has zero standard deviation. So as I said before, the goal is to match the risk of the portfolio with that of the benchmark. So here the portfolio has a risk of 42% or sigma of 42%. We want to bring it down to 30%. How can we reduce the risk of the portfolio to bring it down to 30%? Well, we can create a new portfolio, a hypothetical portfolio that combines this managed portfolio with risk-free asset, right? Put some money in the managed portfolio, put the rest in the treasury bill. As you add more and more treasury bills into this portfolio, its risk will start to go down. So you just want to add enough treasury bills to this portfolio so that the risk becomes exactly 30%, right? So the next step is to actually find out how much do we need to invest in this portfolio and how much do we need to invest in the treasury bills in order to get a combined portfolio that has a risk of 30%, right? Which is the same as that of the benchmark. So this is our target, right? We want the risk of the combination to be 30%. I want to put a certain fraction of my money in this risky portfolio and the other in this risk free. Remember our discussion from chapter 5, combination of risky and risk free. We referred to this as the complete portfolio, right? Complete portfolio. This is what we are going to use here in order to match the risk of our portfolio to that of the benchmark by using treasury bills. So this, if you don't recall this equation from chapter 5 that we actually used, make sure you go back to chapter 5 and look at your notes and textbook information, right? So when you add risky and risk-free assets together, the resulting portfolio, which is the complete portfolio, has a risk which is sigma c, that is given by y. What is y here? Y is the proportion in risky portfolio, right? Y is the proportion in risky portfolio, and sigma p is the risk of our risky portfolio. So here what we are trying to do is we want to get the combined portfolio to have a risk of 30%, and our sigma p, the risk of our managed portfolio, is 40%. So sigma c is 30%, sigma p is 42%. What is the y, right? How much do I need to invest in my risky portfolio and how much do I need to invest in the risk-free asset? So 30% is the target, right? That is what we want. Y is the proportion in the risky portfolio. I don't know what the y should be. And the risk of our managed portfolio, which is our risky portfolio, is 40%. So 30% equals y times 42%. So what should be y? Well, y is just divide both sides by 42, right? 30 over 42, and you get 0.714. You can see that calculation here on the slides as well. 30 over 42, that's 0.714. So that is the proportion in risky portfolio, 0.714 or 71.4%. 1 minus y, right? So that would be 1 minus 0.714, that's 0.286. This is the proportion in T-bills, right, or risk-free asset. So if I put 71.4% in my risky portfolio or managed portfolio, and if I put 28.6% in my treasury bills, right, the resulting combination that I get would have a sigma of exactly 30%. That is our sigma of the benchmark or the market portfolio in this case, right? So I need to put 71.4% in this portfolio, and I need to put 28.6% in treasury bills, right? And I'll get a new combination, new portfolio with the risk that is same as that of the benchmark. So now that I have this new portfolio with the same risk as that of the benchmark, what I can do is I can compute the return on this new combined portfolio and compare that to the return on the benchmark, right? And see whether it is more or less, right? So the risk is same, therefore I can just compare the return. So what is the return of this combination? So here is the formula again from chapter 5, and this is actually a general return calculation formula. What is the return on a portfolio of two assets? Proportion in the first asset times its return plus the proportion in second asset times its return, right? So here you have the risky portfolio and you have the risk-free rate, proportion in risky times its return, proportion in risk-free times the risk-free rate of return, right? And that would be the uh, result or the return on the combined portfolio. So given this, we can actually compute the return on this combination, right? What would be the return? We already have our y's, right? Y and 1 minus y. So we can use that. Y is 0.714. We calculated that here. Y is 0.714 times the return on our risky portfolio. Return on our risky portfolio is 35%. So 0.714 times 35% plus 0.286 times 6%, right? So that's the risk-free rate or the T-bill rate. So that's 6%. So weight in the risky portfolio or managed portfolio times its return plus weight in the risk-free asset or treasury bills times the risk-free rate of return, and that gives us the the return on the combination, and as you can see here, that is 26.7%. Okay, 26.7%, right? So the first step here was to find the weights, right? Y and 1 minus y. The weight should be such that the combination gives us a, a sigma of 30%. Okay, so once we have determined the weights, we know that the risk of this combination is same as that of the benchmark. Then we can compute the return on this combination and compare that with the benchmark. So we have determined that the return of this combination of our managed portfolio with risk-free rate is 26.7%. Its risk is 30%, right? And what is the benchmark return? 28% with the same risk, right? So the portfolio in combination with the risk-free asset, which has the same risk as the benchmark, actually has a lower return, right? Our portfolio has a return of 26.7. The combined portfolio benchmark has a return of 28%. So because this return is less than the benchmark, the portfolio underperformed. Okay, our conclusion would be that the portfolio underperformed on a risk adjusted basis. And what is the M2? It's the difference between the two returns. So 26.7%, the return on the combined portfolio, minus 28%, the return on the benchmark, negative 1.3%, right? So again, both the portfolio earns this return with 30% risk, the benchmark earned this return with 30% risk. So obviously the portfolio did worse than the benchmark for same level of risk. It actually has a lower return. And how much lower? In this case, it is 1.3%. So M2 is minus 1.3, and negative M square implies underperformance. Positive M square would imply that the portfolio outperformed, right? So if you use the Sharpe ratio, you're going to get a similar result. If you compare the Sharpe ratio of this portfolio with that of the benchmark, you will see the same thing, that the Sharpe ratio of this portfolio is lower than the market, right? So you will arrive at the same conclusion, but with this M2 metric, you are actually able to see that performance differential in a percentage metric, right? So that is really the key benefit, that it's easy to interpret, right? How much is the magnitude of underperformance? You can very easily see in this case. Okay, now in your textbook you will see this type of a formula. Okay, you don't need to worry about this formula. I mean, you can just do this calculation based on our chapter 5 discussion, right? Just use those basic ideas, the first principles, and do the calculation based on those principles. And if you understand that, you don't need to memorize or worry about these formulas. So you can completely ignore this formula part here and focus on the calculation the way we did it. So we have looked at various performance metrics. We looked at the Sharpe measure and the M2. We looked at Jensen's alpha and Trainer measure. We looked at the information ratio. And so the question is, with all these different metrics, which one to use in what specific situation, right? The context is important here. And really that goes back to the difference between sigma and beta. So sigma is a total risk measure, right? Includes both firm specific risk and market risk. Beta is a systematic risk measure, captures only the systematic or market risk. So that really guides whether we use a sigma based measure or a beta based measure. So for example, let's say you are choosing one fund amongst number of different possible choices. In that case, if that fund is managed in isolation, then you use sigma based measure like a Sharpe measure or M2 measure. Okay, why? Because the fund might not be diversified. Fund manager might choose to hold a concentrated portfolio. There might be some risk, firm specific risk remaining in the portfolio. So you want to account for that. Some of these decisions are deliberate. There are some portfolios out there, some mutual funds out there that hold like very few stocks. So they're not diversified. So that means if they're not diversified, they have both firm specific risk and market risk, right? And that is by choice. That is what the fund manager is choosing to do. And so you need to account for the fact that individually by itself, the fund might have both firm specific risk and market risk, and therefore total risk is appropriate in those situations. And you use a Sharpe ratio or M2, which is also based on sigma. If you're evaluating a portfolio that is part of a larger portfolio, so let's say there is a fund that is managed by a team, right? So there's like this large fund or a large portfolio, and there are individual parts that are managed by individual fund managers, right? So in that case, what is more important is how much of the risk of the overall portfolio is due to a particular fund manager or a particular portfolio, right? What is the contribution of those individual portfolios to the overall risk of the portfolio? And that individual portfolio by itself might be very volatile. It might have a big sigma, but that does not matter because it is the part of that bigger portfolio. So what matters is the risk of that bigger portfolio, and how much is this individual portfolio contributing to the risk of the overall portfolio. That can be captured by a systematic risk metric like beta, right? So in those situations, a beta based performance evaluation metric like Trainer or Jensen's alpha would be more appropriate. And then in some specific situations, like suppose a fund was managing an active portfolio, and now it is adding some passive portfolio or a benchmark portfolio to the mix. Then because the benchmark is already built into the information ratio, in those type of specific situations, information ratio type of metrics are appropriate. So overall, I mean, it depends on the context, right? What specific context you are looking at, and that would dictate what type of risk metric to use. Okay. All right, so that was our discussion on various metrics, both industry based and academic based metrics that are also very widely used in industry. And then the next thing that I want to talk about briefly is this style analysis by William Sharpe. So, oftentimes we just compare the performance to the benchmark, but that could be pretty noisy. Okay. And there are several different styles, common styles that the mutual funds actually follow, right? So the Sharpe's idea was to account for all those different styles and then look at the performance of the portfolio to see how much of the return is not due to following one of the common styles, right? So let me show you an example here. This is from your textbook. Sharpe identified this various styles which were prevalent at that time. So this was in the early 90s. So you can see like value and growth, small cap and mid cap stocks. Long term is left out. This is a regression. So one of the variables needs to be left out. So what is left out is I guess the long term stocks. So you have short term and long term bonds, you have mortgages, you have growth and value. Europe and Japan were big markets at that time, so they are separately included here, but you also have foreign stocks here. So these are what we refer to as various styles, right? These are the different types of popular funds that are out there, right? Following these specific styles. And so Sharpe's idea was to do a regression, okay? Run the regression of the return on the particular fund for which you are doing the style analysis on this various style portfolio returns, right? So it compute the return on this various style portfolios, do the regression of the fund return on these style portfolios. And this is an example of Fidelity Magellan fund, which used to be an extremely popular, very successful fund. And you can see what the regression evidence shows here. First of all, most of the coefficients here are zero, right? All the bond or fixed income based coefficients are zero. Not surprising because Magellan fund was a stock fund, not a bond fund, right? What kind of a stock fund? So growth stocks, right? So that shows up here. Medium cap stocks and small cap stocks. So small to medium cap growth stocks has some exposure to European stocks, but mostly it is domestic US stocks, right? So small to mid cap growth stocks. That was basically what this Magellan fund portfolio was, right? And then at the bottom you see the R squared here. So you might know what R squared means from your statistics classes. R square is the variation of the independent variable that is explained by the dependent variable, right? So variation of return of our fund that is explained by all these different style portfolios. So 97.3% is explained by following this various styles. What is remaining is something unique that the fund manager is doing, right? So if you focus on that unique part, right, that 2.7%, and see how that is performing, that tells us what is how well the fund manager is doing. That is different from just following these popular styles. So you can see here that this is basically that residual part, right? That is the part that is not explained by those styles, and over time this is cumulative performance. So that residual is actually growing over time over this 5-year period from 1986 to 1990. So that is suggesting that this fund manager did really well. The fund manager was actually consistently adding performance and delivering superior performance. So the overall cumulative performance was increasing over time, right? If you just instead of following or using this different styles, if you just did this kind of analysis with S&P 500, it would be all over the place, right? So very noisy here, right? So that is the benefit of a style analysis, because mutual funds do tend to follow a combination of various styles, and therefore style analysis is useful in evaluating their performance. Okay,